The pattern that we observe in the y column is different if it turns out to be a quadratic function that's going to be used to represent the table instead of a linear function. Now in the x column, we're still going to need to see the same thing that we did before, where we're going to have some sort of consistent addition or subtraction pattern in the x's. Otherwise, what's going on in the y column just doesn't matter. So if we look at the x's here, 0, 2, 4, 6, 8, 10, etc., we are indeed going up by 2 every time. We're following what we refer to as a linear pattern, so we know that the rest of our analysis is going to be fine. So now we need to dig into the y's. And so we're going to do the same thing that we did for the linear function example, where we're going to subtract the second number minus the first, the third number minus the second, the fourth, and so on, minus the third, and we'll continue along that way. So 8 minus negative 4, we go 8 plus 4, so we get 12. Now for the next, we're going to do 12 minus 8, and we can see we get 4. So already we're seeing something different in that we're not getting the same consistent difference between the y's. 8 minus 12 is going to be negative 4. Negative 4 minus 8 is going to be negative 12. We can keep on going. Negative 24 minus negative 4, so negative 24 plus 4 becomes negative 20. And then we can keep on going, but at this point it's not necessary, but that difference is negative 28. So again, we can see that we're not getting the same difference in the y's having subtracted once. But now we're going to subtract the differences. So this is called the first difference. This was constant for the linear function, but it was not constant here in the quadratic. But now if I subtract the differences that I just found, 4 minus 12, negative 8. Negative 4 minus 4, also negative 8. Negative 12 minus negative 4, so negative 12 minus negative becomes plus 4, is negative 8. Same thing, negative 20 minus negative 12, we're going to get plus 12, so negative 8 again. So now we can see that our second difference is consistent. And so that means that we have a quadratic pattern. So as long as the second difference is constant, that's an indication that we have a quadratic function that can be used to represent this table of values. So first difference, linear. Second difference, quadratic, meaning x squared is going to be the highest exponent. If it was not until the third difference that we got a consistent number, then it would mean that x cubed is the highest exponent, so on and so on. So now we want to find the actual equation that this table of values could be represented by. And so, unlike the last one, where it was y equals mx plus b, now it's a quadratic, so it's y equals ax squared plus bx plus c. This is the type of function that we're going to use to represent this table, quadratic. Now the unfortunate part of this is, unlike the y equals mx plus b, where I just have to figure out what m and b are, now I have 3 unknowns that I have to solve for, which means I'm going to need to set up a system of 3 equations and 3 variables. So I need to do that by picking out 3 of the points that are in my table and plugging them in for x and y to build those equations. Now, as I mentioned in the linear example, if we have a point where 0 is the x value, that's going to be pretty useful for us. That's actually going to tell us what c is, because remember, when we're on the x-axis, if we haven't moved left or right, or on the y-axis I should say, if we haven't moved left or right, then that means that we've got the y-intercept, which is what c is. And so indeed, if we start to plug in, we've got negative 4 equals a times 0 squared plus b times 0 plus c. And so anything that has the 0 here, this is going to disappear, because 0 times a is 0, 0 times b is 0. So we end up with negative 4 equals c. So again, if we're fortunate enough to have x equals 0 be one of our data points in the table, then that's the giveaway for what c equals. And so then we're just left with having to figure out what the a and b coefficients are. So let's work on that. we're going to have to set up two more equations to solve for a and b. So I'm just going to use the next 2 points in my table. So to start off with, I'm going to use this 2, 8. So in place of y, because again we're using this equation here, in place of y I'm going to put 8 equals, and then in place of x I'm going to put 2. So a times 2 squared, and then plus b times 2, and then instead of c, since I've already found that c equals -4, I'm going to put -4 right there. Then I'm going to do the same thing for the next point, because I need two equations to solve for these two unknowns. So I'm going to have 12 equals a times 4 squared plus b times 4, and then -4. So before I start trying to solve this system of two equations, I'm going to clean them up a little bit to make them look a little bit more familiar. The first thing I'm going to do is I'm going to add 4 to both sides. So that means in this top one, I'm going to have 12 over here on this side equals, and then I've got 2 squared times a, so it's going to be 4a, and then 2 times b, so plus 2b. So I've just kind of cleaned up that equation a little bit. Then I'm going to do the same thing on this second one. So I'm going to add 4 to both sides, so that gives me 16 equals, and then I've got this 4 squared times a, so 16a, and then plus 4b. So I've just kind of rewritten these equations so that it's a little bit more familiar for when we solve systems. And so now I have to pick which of these variables I want to get rid of so that I can solve for that remaining variable, and then I can go back and figure out what the other one is. So I'm going to go ahead and take this top equation and multiply it by 2 so that I get a match on the b's. So I'm just going to write that right here. So 2 times 12, 24, equals 2 times 4a is 8a, 2 times 2b is 4b. So now I have a match on the b's, and I'm ready to go ahead and subtract these two equations to get those b's to disappear. So if we do that, the b's are gone. I have 16 minus 24 is -8. 16a minus 8a is 8a. And so now we just have to divide both sides by 8. And so we've got a equals -1. So now I have 2 of my 3 unknowns. I know what c is. I've known that for a while. I now know what a is. And so now I just need to figure out what b is, and I can do that by plugging into either of the equations that I have right here. So I'm going to go ahead and plug into this top one. So we've got 12 equals 4 times -1 plus 2b. So I've got 12 equals -4 plus 2b. If I add 4 to both sides, I've got 16 equals 2b, and so then my last step is to divide by 2, and so then I get b equals 8. So now I have my 3 coefficients for my equation. I know what a is, I know what b is, I know what c is, and so then we can write down our equation for this table of values. Y equals, a was -1, so that's going to be -1x squared, or just -x squared. B we just found was 8, so it's going to be plus 8x. And then finally I can replace c with this -4. And so here is our equation for that table of values. And if we have any doubts as to whether or not that's correct, we can always just take any one of these points and verify that they work. So maybe I can jump to this one, I could plug in 6 for x, and then I'd see that my result would equal 8, which is what it should be.